Hello and welcome back. So in this session we are going to work on a short problem. I would say an interesting problem because I believe you all connect with uh, the world of movies, entertainment. So therefore the data is taken from a portal related to that. And my reference for this session, the reference book is Julia Silje and David Robinson's book on text mining with R, a tidy approach, because it's a tidy table as a data structure, okay, instead of table, is what I'm going to use in this particular exercise. So this has got a lot of traction today, the tidy approach to text data mining. And this particular book is something you can buy, or entire text or content is given online, and I have given a reference to that here in the code itself. So, so I will be using the R Studio, which is a platform which runs the R, and I have updated R and installed these packages. The procedure is given right here. If you want to, if you haven't installed, you should first install these packages, and subsequently invoke the libraries or call these libraries when you run the functions from these libraries. Okay, so so the data actually pertains to a discussion forum. As I said, when the movie Slumdog Millionaire was released, there was an intense discussion on the movie, and of course the movie is a lot of entertainment and people like the movie, but there was also a complaint that India was depicted as a country of slums, okay? And that is a major theme of the movie, and directed by British director, but it has a lot of Indian artists in it, and so a lot of confusion and discussion. So that's why I picked this particular discussion forum data. And also, you know, this is something that people from different countries can understand, because this is a Academy Award winning movie. All right, so my effort is to look at this data and also get some insights about what are people talking about, are there good words or bad words or ugly words and so on, and how they correlate, etc. So some basic level of text analysis we can do using this data. Okay, so first step, line 7, I am going to call the library Dplyr, DPLYR, which is a library useful for working with tidy text, and you can read this data and then manipulate this data, create a table, which is a data structure I said for tidy text analysis, all that using Dplyr. Okay, so I am running code line by line. Okay, I can run the code as a whole, I can run line by line, so I am just running this codes line by line. Oh, before that, you know, this is R, right? So I need to define the path. Okay, so the first thing is my data is stored in a particular folder in my computer, so I am going to the file section, and I am going to point or define my path here to the folder where my data is stored. So for me, that data is in MS6842 in the data folder. Okay, so my workspace files pane is pointing to a specific folder where the data is contained. Okay, I notice that this particular procedure is similar to that of MATLAB. Okay, so there is my file pane now points to that particular data folder, and now I say, I go to my session and say what is my directory. I say my directory is the files pane location. Okay, so therefore data will be read directly from the files pane, which point to the data folder where my data is stored. So unless you do this data, you will have to write the complete path if you don't do this. Okay, instead of that, you can just point to the folder. Okay, so let me do this and then start my exercise of the library is invoked, and subsequently I am reading slumdog.txt, which is there in my file pane. You can see that slumdog.txt is right here because my file pane points to that particular folder, and that is my path. Okay, so the data is read as a table into the SD, okay, data frame SD. Okay, SD is the name of the variable or data frame. Okay, now you want to see how this discussion forum data looks like. Okay, it is data is read. Oh, some issue here, I don't know. Okay, I didn't run the previous command, that's why. Okay, see, you can see my data is this, okay, which is available in text format. I read into it, and you can see these are comments or posts by different people. Each post is a document. Okay, each post is a document. Somebody says great film. I should not be reading all these comments because there will be a lot of unparliamentary comments here. So it's an uncensored data. Okay, and don't complain about the data because it's not my data. It is a discussion forum data. Okay, data taken uncensored. And so how many documents are there? If you go down, you'll see 189 documents. Okay, 189 posts. Okay, 189 posts taken as it is. That's my data. Read in viewed. Okay, so now I'm going to give a title to the column. So that is a simple labeling, and then I am defining the data type as character type to take care of some of the issues with the libraries and the functions. And now I am defining a tibble. Tibble is a particular data type or a data structure in Dippler, okay, in tidy text. Okay, it is tibble. It works in tidy text well. Okay, so the data format I am converting as tibble. Okay, or my text one. Okay, which I define now, which contains the text data in document format, is converted to a tibble or a table. You can call it a table in tidy text format. A tibble is nothing but a table in tidy text. Okay. Okay, maybe I didn't execute a line. That is fine. Okay, that is done. And now let me see what the tibble does. Well, you see, a tibble now has two columns. Okay, it's a two-column table. One is a line, it is titled as line. Other column is titled as text. Okay, that was the original table or original column. So idea here is, in a tibble, each row has an identifier. Okay, that line is nothing but an identifier for a document. So document 1, document 2, document 3, it gets actually identified. It's like a key added. A tibble adds a key, okay, to a table to identify each row. Okay, so each document or each document here. So each document has a document identifier. For example, great film doc 1. Okay, they have got free screenings and so on. Document 2. Okay, so that is a key added. Let's have that understanding and move on. Okay, now I am calling library tidy text, which is another library for tidy text. Okay, invoked, and now you see the command line 20 stidy1, which is another tibble that I am creating. This stidy, there is a pipe operator. You know, this is a more recent development in programming. Stid is the source file, pipe, unnest tokens, word, text. Okay, So from the text column, the tidy text document will be unnested into tokens. We discussed tokenization, right? A document consists of tokens, okay? And tokens are what? Tokens can be words, tokens can be punctuations, tokens could be numbers and so on. But here when I use the command unnest tokens, which is a tidy text command, word comma text means word will be the unit, word will be the token, unnesting will be done based on words, okay? And comma, so it will be applied on the data text, okay, the column text. So std has a column called text, okay. So this is the unnesting operation, okay. And sorry, I did something wrong. Okay, now I want to view how std1 looks like, okay. Now you see, after tokenization, the table looks like this, okay. Line means it is the document number, okay. So document 1 has how many tokens? Great has a token which is a word, and film has a token which is word. The punctuation has gone, okay, because it is, the basis is word. Unnest underscore tokens, word, okay, not punctuation. So it removes the punctuations, okay. So document 1, great film, document 2 has so many words, okay, but all of them has the identifier 2, showing that these, each of this word belong to the document 2. So it has kept an identifier, okay. So that is the point. So it is structuring the unstructured data in one sense, we can see it's adding an identifier. So the word got may be there in other documents also, but here the word got belongs to the document 2, okay. All right, let's now move, okay. Now there is a command, interesting command, count, okay, word. So in tidy text there is a count command, using that you can count the number of words, okay. And here itself we have used some descriptive analysis, okay. You see, the corpus has the word the, which has the highest occurrence. 588 times the word the is occurring in the corpus, okay. And is occurring 294 times, I is occurring 273, of occurring 270. But so what? Who is interested to see how many times the has occurred, of has occurred, and so on and so forth, okay. You feel disappointed, and that is why we talked about stop words. We don't want these words to be there in the analysis, okay. These words should be removed from the count. So then we come to the section of stop words, okay. I created this document, this script using the pandemic section. So I've structured it in a way, I had time those days. So this is created in a way you can, section wise the code scripts are arranged, so you can easily follow this, okay. So you can see that in stop words what you see is stop words is a lexicon in the tidy text, okay, library, and we are loading that first, okay. And if you want to see what are stop words like, we can view that, okay. The name of the lexicon, stop word lexicon, is smart, okay, and you can see that there are 1149 stop words. And what are the contents of the stop words? Is, able, about, above, according, accordingly, across, actually, afterwards, again, against. It's a collection of commonly occurring words which we are not interested to sort of analyze for descriptive analysis. So that is the stop words. Now you see, you want to remove the stop words from your original corpus, okay. How is that done? You anti-join, okay. There is a command called anti-join. Anti-join means those words will be, this words will be removed from your original corpus, okay. You see the anti-join command using the pipe operator. So now let us look at the counts, okay. The meaningless, the useless words are gone, as we say. So now let us look at which are the popular words in the discussion forum. Oh, interesting. The word film occurs 163 times, okay. Of course, the discussion is about films and naturally this is going to come. The word movie is 69 times. Again, you are disappointed, right? I don't want to see this. If I have to create a word cloud, I don't want the film or movie showing so much importance because that is understood that this is there, okay. You may want to include the words movie and film as stop words because you don't want them. So then subsequent comments actually, subsequent lines of code does that. If you want to add an extra word to stop word, you can do it like that, okay. This is about adding them and then anti-joining with the added words, okay. So I am creating std3 with the added stop words and counting again, and now I am again looking at the counts. Well, now it makes a little more sense, okay. Boyle, Danny Boyle, Boyle, okay. Boyle is a director, so he is having count of 48, story 38, millionaire 31, Danny 26, Jamal's 26, Slumdog 26, people 74 and so on, okay. Now I am getting to see what is the discussion about. Well, these are the most frequently occurring words, just the frequencies. Okay, and suppose this is incidental. Suppose you want to remove some stop word. Suppose you want the word I is important. Okay, you want to retain that word, or you want to retain the. Okay, instead of the, let me make it I. Okay, and I want to include that. You can do that. Okay, so I thought this will be useful to you when you do actually text analysis, okay. I have included I, it is occurring 279 times, okay, just to sort of learn the method, okay, for stop words inclusion and exclusion, okay. Now we discussed stemming. Okay. All right, we discussed stemming. Now we are implementing stemming here. There is library Snowball C. Okay, Snowball C in R is for stemming. Okay, so commands for stemming are available in Snowball C. So we are actually getting that library Snowball C here, and so you can see there is a command mutate where you can add a line or add a column to a table in steady text using the mutate command. So I am stemming the words that is used from std3 and then counting them, okay, that is line 33. Now stemming is, as I said, to include all forms of a word, okay, be it present, past, past continuous, present continuous, whatever, okay. Now you see the count of the word love, okay, let us go before, okay. How many times the word love occurred before stemming? 20 times, okay. But after stemming, how many times the word love is occurring? 35 times, okay, because it has captured all forms of that word love, okay. You don't miss that. So you see the usefulness of stemming, particularly when you are looking for certain sentiments or certain words which are important to you, okay. So that is the use of stemming. Okay, now let us plot these words in the order of their importance, okay. There are, I again refer to Silje's book, and in that sequence I am giving you the instructions. So ggplot is like matplotlib in Python, is a very useful library for plotting in R. So I am using ggplot2 here. So the library and the words are actually plotted here in the ASK bar chart, okay. So you can see the most important words, okay, after removing the stop words, importance in terms of word counts, okay, these are the words. Okay. So what is the story if somebody asks you in this particular corpus, what's going on, okay, so have a plot of this kind, well, this is what is going on, this is what people are talking about, it's a first impression, okay. And all of you today use word cloud, there are very creative forms of word cloud available. So R has a word cloud library and you can use that for creating a word cloud where the important words have higher font size and unimportant words have lower font size. So that is the way it organizes, it gives you a sense of important words in a cloud format, okay, instead of bar chart format, okay. These are plots you can further improvise on, okay. So I leave this section. Zipf's law is explained in Silje's textbook, and essentially if you look at a corpus as a whole, there will be a lot of unimportant words. Any text, any book or any collection of documents will have a lot of unimportant words, but like the words like the E, accordingly, able, like this, that, etc. Those words are not very important, but that will be the most or the largest number in terms of words that are used, okay. So Zipf's this particular graph actually helps you understand or compare two corpuses in terms of occurrence of common words, okay. Let me first plot this and show you, okay. Here it calculates the term frequency. We discussed what is term frequency, okay. The term frequency, we haven't used stop words here, so we are doing a steady one. So the term frequency is actually the TF, the number of times that word occurs in a particular document divided by the number of words in the document, right? You can see that here. So the word D has the highest TF and so on, okay. So that is the TF that is calculated here, and there is a plot using TF here. Yeah, this is the Zipf's law, which is explained in your textbook, that is the rank of words, okay. The commonly occurring words will have high rank in terms of TF because they are the most occurring. The word the may be the highest, followed by and, etc. So they all come here in terms of rank, and then you can see that this particular part of the graph shows the popularity of the common words, okay. The longer this line or the vertical this line, if this line is occurring for a long region, it shows that a lot of common words are very popular in a given corpus or a document, okay, depending on the unit of your analysis, okay. Ideally, it says this length should be as small as possible so that you have a lot of content that is useful in a document, okay. That's all. Let us move on. Okay, now we are going to look at the TF-IDF together, okay. Importance of words, we saw that more than TF, what is more useful to understand the importance of a word with respect to documents is the TF-IDF, okay. And you can see that TF-IDF is with respect to documents, okay. This is document 117, okay. Okay, so this is the word PA, okay, it is occurring in the discussion, okay. Okay, that is having the highest or PA is having the highest TF-IDF measure for the importance, okay, of words. The word rubbish is having the next highest TF-IDF, which is 2.62. Both are actually the same, okay. and this pertains to the document 117. Okay, and this has got, among all the documents, this is the highest TF-IDF. Among all the documents, this is the highest TF-IDF that is occurring in 117 the document. Okay, and the value is 2.62. So if you have to have a relative sense of which is the most unique and important word and where is it occurring, okay, you go there to the document 117, and these three words have been spotted as having the highest TF-IDF. Rubbish, exceptionally, then strange, perfectly. These are unique at the same time very important words. Okay. Hard to interpret why it is so in this discussion, so I leave it there. Now, bigram analysis, we already have seen that words occur together in documents, that is, co-occurrence. Words also occur in a sequence, that is the n-gram. Okay, and these occurrences are important, and the measures that tell us how often they occur together are also insightful in text mining. Okay, so we again start our tokenization using n-grams. Okay, so n-grams is the basis for tokenization here, that words have high count in terms that they occur in a sequence together. Okay, and when I say n equals 2, or when I give the argument n equals 2 here for n-gram tokenization, okay, it is bigram, then it unnests the documents or tokens documents as bigrams. Okay, and let us see how the bigrams look like. Okay, how many bigrams here? 10,000 or so. Okay, and okay, this is line 1, great film. They have got free screenings free here on the all kinds of, right, here on. Okay, they have got, dev is, when you have an apostrophe, it's taken as one word. So you see a lot of bigrams which are again like not useful for analysis. They should be filtered out. So it is a simple bigram analysis, but you can apply stop words to bigrams as well. That is what is done next, you can see. Okay, let us move on. Let us count co-occurrences. After removing stop words, so there is a procedure for removing stop words from bigrams, and subsequently you see, you look at the word counts. Okay, so those after stop words are removed, you can see there is more meaningful bigrams like Danny Boyle, Slumdog, Dave Patel, Love Story. Numbers are not removed, so they are also shown there. Okay, and how many times they are occurring. Okay, so the bigrams which are meaningful bigrams. Okay, all right. Now you can join them also. Okay, that is just for demonstration. Of course, I am calculating the phi coefficient here, and WIDYR, that is a library which has this pairwise correlation phi coefficient and all that in the tidy text format. You can call that and calculate the pairwise correlation. No problem. So that's what we are doing here. Let us move on, and I'm calling that, and then look at pairs. So here please keep in mind when you go for the phi coefficient, it is not bigram or n-gram, but words that co-occur in a document, okay, that is different from occurring in a sequence. Here in phi coefficient, it doesn't have to be in a sequence. It's only that two words have occurred together in a document and how many times they have occurring. Okay, that is what it is finding out document wise. All right. So you can see Boyle, Danny, movie, film. Okay, they have occurrence together 22 times. So and so on. Okay. Okay, and you see 105th line. Okay, what I am trying to do there is which are the words to which love is associated with. Okay, the two words. So when word love occurs, which are the other words that occur? Okay, so people love films, people love story, people love Danny. How many times? Love movie, love Jamal. You see the usefulness of it. Okay, you fix one word and see what are the other words and their frequencies associated with it. Okay, so it's a simple but very useful analysis. Okay, so you can actually take a word gali. Okay, किस किस को गाली दिया है देखना है तो गाली ले लो and then see which are the people associated with that. Okay, so or if there is a bad word or a good word or all that, you can actually use pairwise association. In a forum like this, there are a lot of abusive words. Okay, I just wanted to caution you that. So phi coefficient is calculated there. Instead of the counts, you can actually look at the phi coefficient. So direction Boyle's that has the highest co-occurrence with a phi coefficient of 0.651, followed by Danny Boyle, Boyle Danny, same. Okay, that is very trivial. Slumdog Millionaire also understood. Salim Jamal, but some of these combinations, when you go through it, may be insightful. Which are the words that are co-occurring? So I also am seeing Danny and its phi coefficients with others, Danny and Boyle, Danny and life, Danny and time, Danny Jamal, okay, and so on. But value of positive but low. Okay. So you can see that the co-occurrence could be analyzed using frequencies. Co-occurrence should be explored using phi coefficient. So you get to see, you take one word and see what are the other words, okay, which are strongly correlated. Okay. So that is a useful analysis with text. And then there is sentiment analysis. This is a simple procedure, and in today's world, most of you do this sentiment analysis either using Affine or NRC or any of this lexicons which are available. And I just run this code and to give a final plot of of the sentiment analysis. Okay. So when you use, say for example, Affine, you get to see the words and their values. Okay. So you get a sense of the scale of these words and which are the ones which are used and so on. Let me get into plot so that you get an overall sentiment also. Leave that, okay, you can do it on your own. And how many negative words, positive words and so on. Okay, these are different lexicons. Okay. You can plot it, positive words and negative words separately, and which are the top ones. Okay, that gives you a sense. Okay. Okay. Love words is where, you know, it's there as a top word here. Okay, and that is having the longest, and that is having more importance than the negative words. So positive words apparently is higher than the negative words in this particular discussion forum. And well, you can look at this. Okay, I haven't censored it as I said, but you can see all words here, and you see both love and hate for the movies plotted together as word cloud. Okay, and that you get a sense, and you can see that love dominates. Okay, and so on. Okay, if you're doing a analysis, or if you want to visualize, okay, overall sentiment in a more visual form, you can use this slides, these scripts which are given. Well, I haven't, I've mostly followed Siljay's textbook, of course, customized it for the given context and data set. Okay, and I will strongly recommend that book along with you when you do, if you're using tidy text, to do a very fundamental level text analysis for frequencies, correlation, and visualization. That's all we have done here. Okay, this is bag of word analysis, not semantic analysis. Okay, that is beyond the scope of our syllabus.